Hello all CMA final students. Welcome to this lecture number 2 on marathon revision for subject strategic cost management. So we have already seen our lecture number 1, which consists of game theory topic. So we have covered 100% concept there. Now we are moving on to the next topic, that is business application of maxima and minima. Well, this particular topic is little tough for non-max background students, because this concept demands little bit of derivatives knowledge. In fact, majority of the problem is solved with the help of derivatives only. So if you focus, if you show some interest, definitely it is an easy chapter. And adding to that, I will also deliver the concept behind that. So that will definitely help you to develop interest and go for the kill. Because this particular chapter is definitely expected in this coming attempt, that is December 25. Expected for December 25. So that is the reason I have been taking up these topics in this order only. Very important from in the order of importance, especially for this December 25 exams. Right, let's kick off with this concept. First, let us understand what exactly is maxima or minima. Maxima or minima just represents, already we have seen in game theory also, it is maximization or minimization. So in business, we all know that our main objective is to increase the profit of the company or growth in the profit of the company. So the question is, at what level of output I am going to get that maximum profit, or what is the price I need to fix to get the maximum profit, right? Or if you want to achieve an objective of minimization of cost, then how many units if I produce, then my cost will be minimum. So these are certain questions for which the answer is there in this particular chapter, that is business application of maxima and minima. So these things, whatever I discussed so far, these are common things which I have been seeing right throughout your entire costing chapters. So here also the same thing we are going to do, but with the help of derivatives. So maxima or minima is nothing but maximization and minimization. Now let us understand what is the problem which led to use of derivatives, because so far you might have done in costing profit maximization problems also. I mean, probably you might have taken 2-3 options and seen which option is giving you the highest level of profit, right? So you might be thinking why we require derivatives. Okay, so let's understand the concept behind this. First, let us just read the core idea behind this particular chapter. Every business aims to make the best possible decisions, that is maximizing profit, minimizing cost, or achieving optimal productivity. In mathematics, these best possible values, this is the important sentence here. In mathematics, these best possible values are called optimum points. That is highest profit or minimum cost. These are called as optimum points. To get these optimum points, nothing but your maxima or minima, we are going to use derivatives, also known as differentiation. This is the thing first you have to remember. Derivatives are also known as differentiation. So to get these optimum points, maxima or minima, we have to use derivatives or differentiation. We will understand why, what is the reason. To apply derivatives, first we need to write profit, revenue or cost in equation form. Yes, if you want to apply derivative formulas, First of all, you require equation. So what is that? Now let us understand with an example here why exactly we require derivatives. Now let us take profit maximization concept. Now we are trying to understand what exactly is maxima and minima and why derivatives are being used. Now I will take profit maximization only. That is, how many units if I produce, or at what level of output my profit would be maximum. How many units should I produce so that my profit would be maximum? Profit maximization. Now, what is option number 1 we have is, option number 1 what we have is, take all the units and calculate the profit for that. This is the first option. So 1, what is a profit? For 2 units, what is a profit? For 3 units, what is a profit? Like this, this is one option, right? This is one option for you to calculate what is at what level of output the profit would be maximum. This particular variable is maximum. That is what you can find out. This is one option. But the problem is, if we have limited number of things we can calculate. So the days during which this concept was introduced, right? So that was time taking process. Hence the option number 2 for us available is a fantastic concept, a fantastic innovation in this mathematical world is derivatives. Option number 2 is we can use derivatives for this. Now if you try to draw this on a graph paper now, as I was telling, other option is derivatives. This is the option we have. So in derivatives what we will do is, first we will try to, derivatives is also called as calculus. Right. In this first what we will do is, we will derive an equation first. Equation for which one? Profit and units. Derive equation between profit and units. Then you need to apply the derivatives to that. This is what we are going to do. Now if I try to plot this units and profit here, because what is our objective here? To achieve the maximum profit or the minimum cost. So now if I apply this derivatives concept now, first I need to draw a equation between these two variables, that is units and profit. So probably this is in the form of a plus what? Bx. This is actually a linear equation. But the thing is, for our outcome is not linear. That is, the profit may not be linear with respect to units, because you know that the cost is consisting of variable cost as well as fixed cost. So it may not be variable with respect to number of units. So in fact the equation will be non-linear equation. So y is equal to a plus bx plus c, something like this. So you will have it is a non-linear equation. It is a non-linear equation. So now from this equation only I need to derive what is the maxima and minima. Now this equation whatever we are expressing is only the objective function here. That means the same relationship I am writing in the form of an equation, then I will apply the derivatives to get the maximum point or minimum point. So if I have to explain this derivatives maximum point and minimum point graphically to you, now x-axis I am taking units, y-axis I am going to take the profit. Now for each unit of output produced, you will get different profit or not? Yes. So if you try to draw this, if you try to draw a line now, it will not be a straight line. It will be a fluctuating line for you, because I told you, it is non-linear. The relationship now, the profit whatever I am getting here is non-linear. That means our profit is not going to vary according to number of units, exactly according to number of units, not in the same proportion. So that is the reason we require derivatives. So now when I try to depict this equation, or say this, let us take the same thing only. If I take these units and profit and try to draw here, then it might be like this, which is non-linear, because this particular derivatives concept only applied for non-linear here. Now my objective is to get maximum and minimum profit for a non-linear thing. So the first option available to us is, as I told you, do it for all the units. We can call this as, trial and error, we can say. This is the first option we have. The second option what we have is derivatives. Okay, let's stop for a moment, just revise what I am saying here. Why exactly we are applying these derivatives, that is the logic I am trying to explain here. Now what is the example I have taken is profit maximize. I want my profit to be maximum. That is, how many units if I produce, my profit will be maximum. This is my objective. Now to get the answer for this, where at what number of units my profit will be maximum. So one option available to us is calculate for each and every unit what is a profit and try to depict on a graph. This is how it will look like, right? Now, but the problem is it is time consuming, because if you produce lakhs of units, now which unit is going to give you highest profit, you don't know. So that is the reason, to minimize the time only derivatives is applied. Now in this derivatives, our objective is to get maximum profit, or this is called as the maximum, and the minimum here, what is the minimum cost? This is what I have to find out. So using this derivatives, what I have to find out is this maximum or minimum. I hope you understood the concept. So if you see here in the core concept here, that is what exactly is being written. In mathematics, these best possible values are called optimum points. Those optimum points, maxima or minima, are calculated using derivatives or differentiation. So to apply derivatives, first what we need to do is express the relationship between the variables in the form of an equation. Then you can apply the derivative formulas to that, right? This is the concept behind this. Now the next thing is here, when you want to calculate the profit, how do you calculate profit here? Yes, I have given profit is equal to, I have given here revenue minus cost. How do you get revenue? Quantity into price is your revenue. And how do you get cost? Variable cost plus fixed cost. So profit is equal to revenue minus cost. Do you think in this the variables, we have here the variable cost, the inputs, basically the variables are nothing but, now we may not have in abundance these inputs. It could be material, labor, or it could be capital, or it could be sales. Do you think it is unlimited? No. So in the real world, we might face some constraint with respect to availability of resources. So to get maximum profit, there could be a hurdle. Hurdle is what? Your constraints. That is limited resources. So now what we need to do is, so in the real world we have constraints. So there are two options for us. One is without any constraints, the other one is with constraints. So we have in our syllabus unconstrained optimization, constrained optimization. So if you see overall our chapter, first beginning is constrained and unconstrained. So first we are going to do unconstrained, then we are going to see constrained part. In fact, constrained part is not so much important from examination point of view. Unconstrained part is only important for examination. So first our focus will be on that only, right? So now if you want to calculate the maximum or minimum points here, there are two possibilities again. You might have single variable or you might have multiple variables also. That is what I have written here. In your equation, you might have single variable or you might have multiple variables. So that means if you have only x in your equation, say, that is single variable equation. But in your equation you have even x and even y also. Then we call it as what? Multiple variables. So single variable, multiple variable. So these are the two cases, two scenarios in our unconstrained optimization. Now for single variable equation optimization, we are going to apply derivatives or differentiation. Now multiple variable equations optimization, we are going to apply partial derivatives. So keep this in your mind. This is very, very important. If it is a single variable equation, you will apply derivatives. If it is a multiple variable equation, that means if you have more than one input, then you should apply partial derivatives. So these are the two types of problems you will have. One is single variable question, the other one is multiple variable question. Now the thing is, in these two cases, how one needs to find out. Now these questions might consist of profit maximization or cost minimization, or at what level of price the profit would be maximum, or what level of output the cost would be minimum. So these sort of questions you can expect in this too, right? So let us start with our first case now. What is the first case? Single variable equation optimization. I hope you are in line with me. Now let's start with this single variable equation optimization. So please remember this, keep this in your mind. This is what immediately you should recollect whenever you think of business application of maxima and minima. Single variable equation optimization, multiple variable equation optimization. For single variable you should apply derivatives. For multiple variable equation optimization you should apply partial derivatives. So let's start with single variable equation optimization. Single variable optimization, what are the steps involved? So here also, what is our objective? Optimization means what? Initially I told you, finding out maxima or minimum, right? So if you want to get this maxima or minima, as I told you earlier, we are applying derivatives. We are applying which one? Derivatives we are applying. So what are the steps involved to get this optimum points? Step number one is, first you need to write, you need to express the relationship between the variables. For whichever variables we are trying to optimize, those variables that should be expressed in the form of an equation. That is the real challenge for any particular firm or individual, because you need to take the help of a mathematician to derive an equation. Yes. Now I am going to just give an example for this. Then you will also understand the formulas, derivative formulas also you can easily understand, right? What I am trying to explain here is, earlier I told you what is the logic why we are applying derivatives. So derivatives are used to find out exactly what is the maximum, at what level of, at what point we will have the maximum or minimum. To apply, to get that only we are using derivatives. Now single variable optimization, single variable optimization. Right now, let's take two variables. Say price, output. These are the two variables. Okay. Say if price is 10 rupees, the output will be, I mean, the unit sold is 100 units. If I increase my price by say 5 rupees, 15 rupees, my output will be say 80 units, right? Now this is X, this is Y. These are my two variables. Okay. Now what is the change now? What is the change in price? Change in price is 5. What is the change in output here? Change in price, nothing but X this is. Change in Y is 20. So if I have to find out now what is the change, what is the change here is change in output with respect to change in price. This is what I want, that is 20 is the change in output with respect to increase in price by 5. So this is 4. I am explaining the logic of the formulas of differentiation. What I am trying to explain is the logic of the formulas of differentiation. So now this change in output with respect to price, how much we got? 4. Now this we need to write in the form of an equation first. Whenever you want to do single variable optimum, this single variable only I have taken. What is the single variable here? Price. Now if I want to write in the form of an equation, this one, how I can write? Y is equal to, can I say 4x, almost 4 times of change in price here. Did you observe that? What is the change here? 20. Change is 5 now. The change here, if price is increasing by 5 times, is increased by 20. That means 4 times is a change. So this is how you can write in the form of an equation. This is how you should write in the form of an equation. Right? Now, so if you want to now apply derivatives to this, how you should write this is dy by dx is equal to of 4x if you take. So now say basically how it is represented is delta, no? Yes, or say x something like this. dd gets cancelled here. Now what exactly we are left with now? 4. right? So dy by dx here is nothing but your derivative here. Dy by dx is nothing but your derivative. So the derivative of this is exactly 4. The derivative of this equation is, once again I am writing here. First what I have done is I have expressed this, the relationship between these two variables in the form of an equation first. Now we should apply the derivatives. This is what exactly we need to do. Now what I am trying to tell is how the answer for a derivative we got. That is what I am trying to explain here. So I hope you got an idea of how equation is set first. I gave you a basic idea. On this only we will apply the derivative formulas. So you need to have an idea of even derivatives formulas, and then little bit of economics knowledge also you should have, because revenue, profit, calculation also you should know. Yes, these are the two things you should know. So I hope now you understood how we should set an equation first. This is the first step whenever you want to get maxima or minima with respect to single variable, right? Now let us go back to our summary notes. So that is what exactly the first step I have written here. Write function or equation between variables represented by z. So the function will be represented by z is equal to, say for example, profit is my objective, maximization of profit, then total revenue minus total cost. So that will be in the form of z. So z is equal, something like z is equal to, the equation will be. Now then the next step is very important, that is apply the first order derivatives of the given equation. We should apply the first order derivatives of the given equation. Nothing but we should use derivatives. We should use the derivatives here. So to apply derivatives here, you should have the knowledge of the formulas. You should have the knowledge of formulas here. So if you see here, I have written that only to calculate maxima and minima points, we need to have knowledge of derivative formulas. So step number 1, already I told you that we need to first, whatever we want to achieve, that you should express in the form of an equation. If I want to get a maximization of revenue, then revenue equation you should write. What is the revenue equation? Revenue is equal to price into quantity. This is revenue equation. Then if you want to get profit, profit is equal to cost. How do you get cost? Total cost is equal to variable cost plus fixed cost. Variable cost, again units into variable cost per unit plus fixed cost. Equation. Profit is equal to revenue, my total revenue minus total cost. If you do, you'll get what? Profit. So that equation first should be written. Then step number 2 is you should apply the derivative, first order derivative. That means first time you should apply the derivative to that. And what is the symbol we should use for this first order derivative is f of x. See, f here, it's like, it will look like an hyphen, it will look like exactly an single inverted the comma there. This is one way to represent this. This is the first integration. This is one way to represent it. Other one is dz by dx. Dz by dx. Most of the problem we'll use this only, dz by dx. Alright. Then again we should apply the, that is second time also again we should apply on this to check whether we have achieved the target objective or not. Right. So hold on for a minute. Take a breath. Now, what are the steps involved in optimization of single variable? That is what we are covering. First step is, first you express that whatever objective you want to achieve in the form of an equation. Then step number 2 is you should apply derivatives. Okay, stop here. Now let's understand the derivative formulas. Right? If you apply, if you know the derivative formulas, then easily you can understand these notations also. Then we can go through the remaining steps also. Right? Or quickly I will give you steps, then we'll go to the formulas there. Step number 2 is we will apply first order derivatives. This is the necessary, this is also called as necessary condition. That means first time we are doing differentiation, first time differentiation. Then whatever value we get, that we equate with 0 to find out the x value in that single variable. To find out the x value, we need to equate the first order derivative, whatever result we got, that we will equate with 0. So that I will get x value. That single variable value I will get. Okay. Then step number 4 is to confirm whether we got maximum or minimum points. We need to check one more also. That is only called as sufficient condition. That is only called as sufficient condition. So again, whatever answer you got here after step number 2, on that you need to apply again derivative. That means second time you should do again differentiation on step number 2. So that how you do express here d by dx of dz by dx. So d square z divided by dx square. This is the second time we are doing for the step number 2. Once we do this, okay, then substitute the value of x, whatever you got in step number 3, in the result of step number 4. Whatever you get after applying second order derivative, in that equation substitute the x value. And if the value is less than 0, then what we can say that we have achieved a maximum point. That means the maximization of profit is achieved at that particular point. What is the condition to be met? Your second time derivation value must be less than 0 to say that we have achieved the maximum point. So if you have to represent in the graph here, see here, I told you earlier it will be non-linear, no? So if I want to find out what is a maxima here, this is a maxima. This is the maximum point. The first time to get this, right, we are to check this whether it is maximum or not, we are doing second time derivation, right? So what I am saying here is, if the value is less than 0, so what that indicates it is decreasing. So that means what? The point, whatever we got, maximum point, that is really a maximum point only. If you get negative value, what is the meaning of that? Right after that point, what is happening is, you are getting negative value means there is a turn. So we need to confirm that by doing second order derivative. Okay, first time to get what is the change we are calculating, second time to confirm, first time we are doing to get the maximum point, second time we are getting to confirm that. So it is a checking condition basically. So if it is if the value is less than 0, second derivative value is less than 0, second time after applying derivatives, the value of that after substituting the x, that is what written here. If d square z divided by dx square is less than 0 at the value of x obtained in step number 3, then z is the maximum at the value of x. Right. So this is what. So now if it is less than 0, this is what indicates. What that indicates is now the curve is coming downwards. If it is less than 0, the curve is coming downwards. So that is what it indicates. So if it is coming downward means the point whatever we got is a maximum point, because we are getting the second time derivative we are doing to check whether it is really a maximum point or not. So when second time derivative value is negative, it indicates that it is decreasing. That curve is what? Decreasing. So that is how we should confirm that yes, it is a maximum point. Similarly, if you want to say that we have achieved the minimum point, whether we got the really minimum point or not, it's reverse. Greater than 0 it should be. If d square z divided by dx square is greater than 0 at the value of x obtained in step number 3, then z is the minimum at that value of x. So see here in the diagram, This is the minimum point. Through first order derivative we are getting. To confirm this, we need to do second order derivative, and if it is greater than 0, that means it is rising. The second order derivative value is rising, so that indicates that it is the minimum point. Whatever we got earlier is the minimum point. After that point, what is happening? There is a shift, upward shift here. So why second time derivation is done is to check whether it is a maximum point or minimum point. That is the reason why we do the second time derivation. Alright, so remember the steps. Step number 1 is equation first. First you need to express in the form of an equation, then apply first time derivative, first order derivative, then equate with 0 to get x value, then again apply second time derivation differentiation on the step number 2 value, step number 2 equation, then whatever equation you get, in that substitute the x value. The value, if it is less than 0, that confirms that we have achieved the maximum point. If it is greater than 0, that confirms that we have achieved the minimum point. So these are the conditions. I hope you understood just steps now. Now, as I told you, without knowing the formulas, you cannot solve this problem. Yes. Now what I will be doing is, let us go to the formulas. Once you know the formulas, then easily you can apply the differentiation. Right? So derivative formulas, here they are. The first formula here, first of all you should know what is dy by dx. Earlier when I was giving you the concept, okay, how the relationship is determined in the form of an equation, there I use this only. This is basically delta y divided by delta x only. The change only it represents. So dy by dx is nothing but what? Change in y with respect to change in x. That is what dy by dx means. This is only the first, that is differentiation this is. A second formula now, d by dx of a is nothing but a constant. So any differentiation on a constant, the answer is 0. D by dx of a is a constant here, any constant now number. So that means if say d by dx of, you are saying doing 3 is a constant, so number. So for that, what is the answer? The answer is 0. So any differentiated value of a constant, answer is always 0. So this is the first formula. So d by dx of any constant is equal to 0. Next, d by dx of ax. So if you have a d by dx of, I want 3x value. In this 3 is a constant here. Now how to get the value of this is, now d by dx of 3, okay. Anyhow, d by dx of 3, other one is d by dx of x. So d by dx of 3 is any derivation, any differentiation of constant is 0. Into what is the, but the thing is it is not plus here, d by dx is 1. So in this case, it is not just constant here, it is mixed with another value, that is x here. If it is only a, the answer would have been 0, but it is with what? X. So in this case, how to get the value of that is a into d by dx of x. First you separate the constant, right? Say for example d by dx of 3x, in our question we got 3x, then the answer for this is 3 into d by dx of x. So 3 into d by dx by x, dx is 1. So 3 is the answer for this. So whenever a constant is with other value, other input value, then constant you separate and then take the differentiation of the other variable. So a into ax, differentiation of ax is a into differentiation of d by dx of x. Next one is d by dx of e power x is e power x. This is the answer for that. D by dx of ex is equal to ex. So e value is 2.718. Right. Next one is d by dx of x power n. The formula for this is n into x power n minus 1. N into x power n minus 1. Now, say now you have to do differentiation of x square. Then tell me now what is the answer. 2 into x power 2 minus 1. 2 into x power 2 minus 1. So 2x. So n into x power n minus 1. Remember this formula. D by dx of x power n is n into x power n minus 1. Very important this is, especially when you get squares or cubes also. Next, d by dx of e power mx. E power mx. So m being a constant, that you separate it first, and then e power, it's like e power x only, no? So take as it is e power mx. So m is a constant here again. So d by dx of e power mx is m into d by dx of mx is nothing but mx value only, then that is e power mx. Whenever e is their base, take the same. But if it involves any constant, take the constant first, separate the constant and then take e power that value. So m into e power mx. Next one is d by dx of log x is 1 by x. Remember this formula, d by dx of log x is 1 by x. Next one is d by dx of u into v. U into v. U into d by dx of v. U into first, then differentiation of v, then v into differentiation of u with respect to x. Differentiation of v first with respect to x, then differentiation of u with respect to x. So u into differentiation of other one, then v into differentiation of first one. That is what you have to know. Next, d by dx of u by v. D by dx of u by v here. So same thing here, only thing is minus you will get. So v into first, then d by dx of u minus, instead of plus you will have minus u into the other one derivation with respect to x divided by v square. If it is u divided by v. If it is u into v, then no divided by, that is what you have to remember. Next one is d by dx of u plus or minus v is equal to d by dx of u plus or minus d by dx of v. So these are the formulas, some formulas here, not all the formulas, some formulas which are given in your institute material, that is what I have taken here. So these formulas will definitely help you to crack the problems, right? So earlier when I gave the concept here, so how they see here, now you will understand. Earlier I was writing, no, this is the equation, now I have to apply derivatives. Now you tell me what is the answer. Dy, now I want a derivation of this one, dy by dx. Now you tell me, dy with respect to, so that means derivation of this equation, the equation y with respect to what, x, is equal to dy dx of 4x. So derivation of this, so what is this value? It is like a into x only, no? So what is the answer for that? Answer was 4 or not? Yes. So that is what I was explaining earlier. Okay, what is the logic of this formula? That is what I was explaining, right? So now I hope that you might have understood this. For this equation I have applied derivative here. So real challenge is how The relationship between two variables is expressed in the form of an equation. Once you express that in the form of an equation, then you can apply the derivative. Got it? Yes. And then remember all the formulas here. What are the formulas? D by dx of any constant is always 0. Next, d by dx of ax, that is constant into another variable, that is a into ax, derivation is d by a into d by dx of x only. So that is a into 1. D by dx of x is 1 always. So a into 1. So answer is a. So earlier d by, if I want to find out what is the derivative of 3x, the answer is what? 3. Yes, or 4y. What is the answer? With respect to y, if I want to do derivation, then it is 4. With respect to x, we are doing derivation, remember, because x is the only variable here. The only single variable we are doing in the first case. Yes. Then e power x, only e power x will get x power n. This is very important formula. Very important formula, x power n. So x square, derivation of this one, you tell me. 2x 2 power minus 1. So that is 2x. If it is x cube, then 3 into x power 3 minus 1. That is 3 into x square. If it is x power minus 1, tell me what you will do. X power minus 1. Minus 1 into x power minus 1 minus 1. So minus 1 into x power minus 2. How I can write this? Minus 1 by x square. Yes. Log x is 1 by x. U into v is first u into the differentiation of v with respect to x plus v into differentiation of u with respect to x. If it is divided by, then put minus divided by v square. That is the additional thing we are doing here. U plus or minus v is both derivation, plus or minus you should put in between. So this is what you should remember. Okay, these are the formulas. To do single variable problems, formulas first. Next thing is, you should also know little bit of fundamentals of economics. Right? This already you might have learned it at foundation level economics also. So this is not something new for you. Easily you can connect this. Variables for which maxima or minima is required. Basically, for which variables we require maxima or minima? It could be profit, it could be cost. So those are the variables or not. How to calculate those variables? That is what we are learning. First thing is how to calculate revenue. Total revenue is equal to, how do you get total revenue? Price multiplied by quantity. Price multiplied by quantity. How do you get average revenue? Average. So we have to divide total revenue by the quantity. Total revenue divided by quantity, you will get what? Average revenue. Marginal revenue. Marginal revenue. Marginal revenue is nothing but d by dx of your total revenue. This is nothing but change in total revenue divided by change in total quantity. This is. So marginal revenue is nothing but d by dx of your first order derivative of which one? Total revenue. The first order derivative of your total revenue is called as marginal revenue. Remember this is important point. Because I told you that derivatives is nothing but change only, no? When I gave this example, when I was trying to explain the relationship between two variables, if you remember, here it is change only. Derivation is nothing but change or not? This one. So this change is only 4. Directly without formula, directly we calculated or not? What you have to understand from this is, equation you set aside. Directly I have shown you what is derivative. This is only derivative. So dy by dx is equal to 4. The answer is 4. So this is incremental change only. No, this is marginal revenue is nothing but basically what is the change in revenue with respect to one additional unit. That is only marginal revenue. So here this is only marginal. So marginal revenue, how do you get? The first order derivative of your total revenue is only your marginal revenue. This is nothing but what? Change. So with the concept whatever I taught you, now you might be understanding what exactly is MR. What is derivative? Derivative is nothing but what? Change. So MR over. Now similarly cost things also you should know. Okay, quickly remember this. Marginal revenue is the first order derivative of total revenue. Nothing but change in total revenue with respect to change in quantity, that is marginal revenue. Yes, this is what you might have learnt in economics also. What is the change in total revenue with respect to change in quantity? For every one additional unit of output, increase in output, what is the change in total revenue? That is only marginal revenue is. And that change is only we are calling it as derivative, first order derivative, that is. Yes. Now, cost related. How do you calculate total cost? Total variable cost plus total fixed cost. How do you get total variable cost? Variable cost per unit into quantity and plus total fixed cost. So, if you assume variable cost per unit as M and the quantity as X and total fixed cost as C. Okay. Now average cost, how do you get? Total cost divided by quantity. This is how you get average cost. How do you get marginal cost? The change in total cost with respect to change in output is only your marginal cost. This is nothing but the first order derivative. D by dx of total cost is only called as marginal cost. Remember this MR and MC. Okay. Change in total revenue with respect to the quantity, that is MR. Change in total cost with respect to quantity, one unit, that is MC. The first order derivative, that is. Alright. Next. Now profit. How do you get profit? Profit is equal to total revenue minus total cost. Or next, how do you get average profit? Average revenue minus average cost you can take, or total profit divided by total quantity. If you do like that also you can get. Here it is profit is represented by pi. Profit is represented by pi here. So average profit is total profit divided by the quantity. Now how I can get this alternatively is average revenue minus average cost. Also I can get average profit, because earlier I got average cost, average revenue. Average revenue minus average cost also you will get average profit. Marginal profit. How do you get marginal profit? One is marginal revenue minus marginal cost we can do, or the derivative of total revenue also you can do. So what is the change in total, not revenue, profit? The change in total profit with respect to change in output. So the derivative of the total profit. Like that also you can get. Right? So I will introduce these three terms first. So what we have learned quickly, just revise. We are doing the first case in business application of maxima and minima. In this, the first case is there will be one variable equation, multivariable equation. Right? So equation, if it has only x, then it is single variable. If it has x and y also, then it is multivariable. Right? First we are doing how to get maxima or minima for single variable equation. So if you want to get optimization, that is maxima or minima for single variable equation, then what are the steps involved? Step number 1, first you should write the equation, express in the form of an equation. Objective function you should decide, whether profit maximization or minimization of cost. Then step number 2 is we should apply the derivative on that. The first order derivative. It is represented by d by dx of the function z. d by dx of the function z. F hyphen x also we can use. This is also another notation. I don't know whether exactly the correct term I am using or not, but mostly we are going to use this only. That is differentiation of function z with respect to x. That is a correct way to technically speak. Now once you apply the derivatives, the formulas, okay, first time you have applied, okay, then step number 3 is whatever value you got after applying the first derivative, that equation equate with 0. You should equate with 0. Why we should equate with 0 is to get that variable figure, that is x value. To get x value, equate with 0. This is what we should do. After that, the next thing is very interesting. What is that is, again we are applying the differentiation on which one? On the first step number 2, whatever we got, on that we are applying again difference. You can see here d by dx of dz by dx. Why we are doing this is to confirm whether we got maxima or minima. To confirm whether we got maxima or minima, we have to apply this derivative second time. Second time we should apply the derivative to check whether we have achieved the maximum or minimum. How we can check that is, this is the condition. When we can say that yes, the value, x value, whatever we got is, now one more important point here is, stay here. Step number 4, we are doing a second time derivative now. Yes, whatever you get equation, in that you substitute x. Now x value we got in step number 3 now. In that you substitute x value, then that value is less than 0, then you can confirm that that is the maximum point. If it is greater than 0, then it is minimum. So you might think reverse here. No, it is not reverse. There is a technical reason for that. What is the technical reason? We know that this is maximum, this is minimum. That is okay. By first order derivative we got that. Now second is to confirm whether that is maximum or minimum. Now how I can confirm that it is maximum is, if my curve is bending down, right, then that is an indication that the point at which we calculated this value is a maximum point. So that is if it is coming down, naturally values will be negative only now. If it is coming down, so that is the reason less than 0. At the value of x obtained in step number 3, then z is maximum at the value of x. Because after that, if you increase your output, what is happening is the value is 0. Beyond that, if you increase, the value you are getting 0. That means the point, first point where whatever we got at that point only we are getting the maximum. After that, still if you increase your output, what is happening? It is coming down. That is the reason we are saying that that is a maximum point. Similarly, now tell me what is the condition we should satisfy for a minimum point. If you increase your output, if you get positive values, if it is increasing, that means the previous one is the lowest one. So to confirm that only we apply again second time derivative here. So that is what we have indicated here, right? So this is your sufficient condition. Now you can say, sir, if it is exactly equal to 0, what does it indicate? Now earlier less than 0 or greater than 0 I have taken, no? Yes, exactly 0, what does it indicate on the graph is, it is like, flat, it is flat. Neither it is increasing nor it is decreasing. It is like flat. So whenever d square z divided by dx square, if it is 0, what does it indicate? It indicates that there is neither maxima nor minima. First time we are equating with 0, no. So there is no maxima or minima. So whenever it is 0, you can say that there is no maxima or minima at that point, right? So these are the steps for single variable. So to do single variable, you need to have knowledge of formulas, the differentiation formulas, and then economics, TR, AR, MR with respect to revenue, cost, total cost, average cost, marginal cost, then profit, total profit, average profit, marginal profit. These are the three things you should know. That is what we have written here. Okay, equilibrium we will discuss slowly. First, on this concept, let us do the problem now. Students, I know that I cannot call this exactly as a revision also. The reason is, full concept I taught you here. What is the reason for this is, students, without knowing the concept, you cannot do these problems. If I just quickly make you to read, go through all the formulas here, that doesn't fetch you anything. There is no purpose. The reason why I'm giving you this marathon is, my objective is each one of you should get exemption in SEM. That is my objective. So in this chapter, especially without knowing concept, you cannot do the problems, right? And even if you want to remember also, you should have that knowledge. So let us do a problem now. Problem number, let's take one problem from institute material only, or I will give you one problem now. So what are the steps here? I am writing quickly. What is first step? Single variable optimization. Single variable optimization. First step is equation we should take. Second one is first order derivative. Okay, that is dz by dx. With respect to x, we are differentiating. Step number 3 is dz by dx must be equated with 0 to get x value. Then step number 4, what we need to do is, sufficient condition we need to check whether we get maximum point or minimum point. For that, again, second order derivative we need to apply. Second order derivative. That is, again we are differentiating the step number 2. So d by dx of dz by dx. So we can call this as d square z divided by dx square. Okay, so this you should get. Now after that, what you need to do is conditions, interpretation. Substitute now x in d square z dx square, substitute x value in that. If d square z divided by dx square is less than 0, we can say that it is, we can confirm that yes, it is a maxima. Yes. If it is greater than 0, then we can confirm that it is what? Minimum. So these are the steps for solving single variable optimization. In your equation, if you have single variable, of course formulas also you should know. The next thing what we have learned, how do you get total revenue? Total revenue is price into quantity. Average revenue is equal to total revenue divided by quantity. Marginal revenue. Marginal revenue is nothing but d by dx of total revenue. Okay, next, total cost. Total variable cost plus total fixed cost. So AR, AC, TC divided by quantity, X, MC, d by dx of total cost. And how do you get profit? Either TR minus TC, average profit, average revenue minus average cost, and marginal profit is equal to MR minus MC. Right? This is what you should know. Let us take one question here. First question. I will take one question. CMA material question only I am taking. One example. The demand writes, the demand nothing but writes per day of roller course, or what I will do is I will show you institute material directly so that I will not waste your time. Yes. So you can see the formula, all the formulas here. Business application of maxima and minimum. So optimization functions involve single independent variable. Single independent variable. Necessary condition. First order derivative. Sufficiency condition is second order derivative. See, this is the first question. Illustration number 1. The demand of roller coaster ride in an entertainment park is one of the metro cities is given by the equation Q is equal to. So which equation? The demand rides per day, right? How many rides per day they have given? It's like quantity for you. Here demand is nothing but what? The quantity. How many rides per day in an entertainment park is given by this equation. So this is like your rights, the quantity is like quantity. Okay, that equation they have given. See, which equation this is given? Demand equation is given, quantity equation. Next, where P is equal to price per ride in rupees. What is P here? The price per ride. Okay. What price should have been charged to maximize total revenue here? So what is the single variable here? What is the objective? First of all, maximization of revenue is the objective here. What is the objective? Maximization of total revenue. So how much price you should charge? So what is the independent variable here? Price. Price is the independent variable here. So how much is this single variable is price here? How much price if you charge to maximize the total revenue? So what is the first step here? Step number 1. Illustration 1, your ICM material. First equation, no, step number 1. Z is equal to, what is the equation they have given? Minus 450p plus 41,500. Okay, so this is the equation they have given. Now this equation is it total revenue? First of all, no, it is not revenue. Step number 1 is quantity is given. Q is equal to minus 450p plus 41,500. Okay, this is only quantity, and P represents here what? Price. So now what I want exactly is, now I want total revenue. How do I get total revenue? Total revenue is equal to price into quantity. This is how we get total revenue. So now we know the quantity. As I told you earlier, this is a quantity equation. So let's assume, then what about price here? Price also we should get now here. So how I can get price equation here? This is, you see the question, Q represents, Q is equal to minus 450p plus 41,500 exactly represents what is the number of rides, that is. Basically it represents quantity, that is okay, fine. Now what about price? So we need to multiply the price with what? Our quantity. So now here the question is, how do we get the total revenue? Total revenue indicates nothing but here price into quantity. So what is your price and what is the quantity here? Let's take price as P only. Okay, and what is the quantity? Your quantity is minus 450, because in the question P represents price only, no? So minus 450 P plus 41,500. So total revenue is minus 450 P square plus 41,500. This is your total revenue, TR. Now what is your objective? What is the given in the question? The objective is maximizing total revenue. So this is only your function. Total revenue only you should maximize. Alright. Now step number 2. So this we will represent by Z. Okay. Alright. So step number 2 is first order derivative. First order derivative. That means first time we are applying the derivative here. With respect to x. Here don't take it as x here. What is the input name we have given? P. Right. So dz by, first let us take the equation. Z is equal to, name doesn't matter, okay, 450 by 41,500. Right. So dz by, we are going to differentiate this function z with respect to p now, because p is the variable now. So dz by dp, don't say sir x no. So when the input is x, then differentiate with respect to x, but the input is p now here. So dz by dp is equal to so minus 450 into p square. Tell me now, it is like x power n. With respect to p only we are differentiating now. So d by dp of minus 450 p square plus d by dp of 41,500. So this is equal to, this is like a into x, do you remember? Yes. So minus 450 into 2 power 2 into p power 2 minus 1. This one is d by dp of a constant, no, 0. So this is minus 900p. So dz by dp is equal to what? So your MR is equal to minus 900 into P. This only we call it as MR because this is the first derivative of what? Your equation. So minus 900P is the first order derivative we got. So now you can understand that without knowing the derivative formulas, can you get this? No, you cannot get this. So x power n we applied here. Yes. This constant, no? 0. Now step number 3. What we should do? Step number 3. We should equate this with 0 to get P value. So dz by dP is equal to 0. We should equate with this 0. So minus 900P is equal to what I missed here is this P I missed here. When I multiplied with this equation here, minus 450 P square and 41,500 into P, I did not multiply there. I forgot that. So if I take P here, it is not a constant then. If it is not a constant, then d by dx of 41,500 into P, then if you remember, what is the answer for that? First you should separate the constant, then d by dP of P, that is 1. So 41,500. 41,500 into d by dP of P is 1. So minus 900P plus this one is 41,500. Okay, I missed that. Now you should equate this with what? 0. So minus 900P plus 41,500 is equal to 0. Why we are equating with 0? To solve for P. Instead of X, I am naming it as P only. I took the same wording whatever they used in question. So minus 900P plus 41,500 is equal to 0. Now minus 900P is equal to 41,500. P is equal to 41,500 divided by minus 900. $41,500 divided by 900, 46 point you are getting 46.11 you are getting. Yes, minus 900P, if it goes this is minus, this is also minus, so both will get cancelled. Now it is positive only, 46.11. P we got 46.11. What is this price? In terms of rupees it should be. So we got the P value. Now step number 4. Now we should confirm whether we achieved a maximum or not. Is it the maximum? It is a price at which the revenue will be maximum or not? That we should confirm now. What we should confirm? At this price, whether the total revenue is maximum or not, that is what we should confirm. So how to confirm that is by again differentiating this step number 2. Second order derivative now. Second order derivative. Second order derivative. So d by dP of which one? Your first one, that is minus, that is d by dz by dP. Of this one only, whatever we got, minus 900P plus 41,500. So what do you get? D square z by dP square is equal to, with respect to P we are doing no. Again we are doing that. So minus 900 d by dP of P is what? 1 only, no. So minus 900 and d by dP of the constant is 0. So we are getting minus 900. D square z by dP square value we are getting minus 900, which is less than 0 or not? Yes. So since d square z by dp square is less than 0, okay, the price whatever we got 46.11 will give you the maximum revenue. That is what it confirms. What we should write here is at P is equal to 46.11, total revenue is maximum. Total revenue is maximum. Now we should calculate the total revenue. Did they ask total revenue? See the question now. What price should have been charged to maximize the total revenue? So only price they have asked. They did not ask total revenue. If they ask total revenue, now easily you can substitute in the original equation. Okay. The original equation, if you substitute, you will get the value there. So you can check the answer now. You can see here 46.11. Thus the price to be charged to maximize the total revenue is 46.11. I hope you understood, everyone. This is a simple problem here. Single variable. Okay. What is that variable here? Price. What price we should charge to maximize the total revenue. So first we form the equation total revenue. Then total revenue, how do we get? Yes, that is also very important. Whatever they have given is, which equation they have given? Quantity equation they have given. Number of rights equation they have given. That is not total revenue. Don't get misled by that. Clearly given. The demand, nothing but the rights per day. That is the quantity equation. So let's take price as P. So P into Q. If you multiply price into quantity, that is. Why I took price as price P only is because in the equation it is taken as P only. Why I did not take X, you know? In the equation already P is there now. So that is the reason price I took it as price only instead of X. Got it? Yes. So this is single variable optimization. How to achieve the maximum. Right? Now let's take another question here. With cost we can check. Minimization problem. Quickly this also will go through. Assume that cost, that is rupees of manufacturing X numbers of a product per day. So cost function they have given. Assume the cost in rupees. Manufacturing X number of products per day. So directly they have given now cost function. This is total cost function they have given. So only one variable is there. This is a function. How many of the products should be manufactured per day so that the average cost is minimum? AC, average cost. How do you get average cost? Total cost divided by the quantity, which they have took it as X no here. Yes. So everything is ready. So what is the objective here? Average cost is minimum. Also find the values of average cost and the total cost. Also find what you have to find out. Average cost you should find out, and then total cost also at that level we should find out. Now it is, since the objective is to minimize the average cost, right? So last it should be greater than 0 or less than 0. Second order derivative, it should be greater than 0. So let us do minimization now. Illustration 2 quickly. Illustration 2. What is the objective? Objective is minimization of average cost, not total cost, average cost. First you should get total cost. What is the total cost equation given? X is equal to 14,400 plus 550x plus 0.01 x square. How do you get average cost? Average cost is equal to total cost divided by x, no? Quantity. Yes, that means 14,400 divided by x plus 550x divided by x plus 0.01 x square divided by x. X, 1x gone. So average cost is equal to 14,400 divided by x plus 550 plus 0.01x. So this is your average cost. Now this I should minimize. So this is my equation, first equation. Okay. This is your cost equation, average cost equation. Step number 1 this is. Step number 2 is first order derivative. First order derivative. So d by dx of what? Your average cost, not total cost, average cost is equal to d by dx of 14,400 by x. D by dx of which one? 14,400 divided by x plus d by dx of the constant 550 plus d by dx of what? 0.01x. Let us get the value. Now how I can write this 14,400 divided by x is 14,400 into x power minus 1. I can write like this. 14,400. Non-max background students, okay, probably might face little difficulty here. 1 by x can be written as x power minus 1. Okay, then it will become like x power n. Then what is the derivative of this? N into x power n minus 1. So 14,400 into minus 1 into x power minus 1 minus 1. Okay, plus d by dx of constant is 0. D by dx of constant into this one is, you will get a constant only, 0.01. So now here 14,400 into minus 1 into x power minus 2 you are getting. So can I say minus 14,400 divided by, can I write now x square? Yes, plus 0.01. This is your first order derivative. Right. Now step number 3 is d by dx of your average cost must be equated with 0 to get x value. To get x value. Right. So let us equate now. Minus 14,400 divided by x square plus 0.01 is equal to 0. Now if this goes that side, that will be positive. Yeah, 0.01 is equal to 14,400 divided by x square. Then x square is equal to 14,400 divided by 0.01. X square, how much is the value of this? $14,40,000 we are getting. X is equal to square root of 14,40,000. So apply square root on this. You are getting x is equal to 1200. You are getting x 1200. So x value we got 1200. Now step number 4, what we need to do? Second order derivative to check the condition. Second order derivative. So already whatever you got in step number 2, again we should apply differentiation on this. So d by dx of which one? D by dx of AC. this one I want, is equal to, so again minus 14,400 divided by x square is there, no? Again x square, how I can write? Minus x power minus 2. Then again minus 2 into x power minus 2 minus 1. So minus 2 into x power minus 3. Minus 2 into minus 14,400 plus. So how much it will become? 14,400 into 2. 28,800. 28,800 divided by, it will become x cube. X power minus 2 minus 1. X power minus 3. So how you can write? Divided by x power 3. And d by dx of the constant 0.01 is 0. So 28,800 divided by x power 3 plus 0. This is the value. Now put x is equal to 1200 in the above equation. If we put that now, 28,800 divided by 1200 power 3. Okay, what is the value of this? Definitely a positive figure only, no? So this is definitely greater than 0, which is greater than 0. Do you agree? Yes, it is greater than 0 only, no? So instead of again calculating that, why to do that? So greater than 0. So since greater than 0, that means what we have achieved? Minimum we have achieved. That means whatever we got no value here, 1200. So 1200 will give you minimum cost. If you produce 1200 units, then your cost will be minimum. So that is the answer. Since d square divided by dx square is greater than 0, 1200 units will minimize total cost, So let us check the answer now. So minima we got here, so answer is 1200 only. Yes, here I took only positive value here. Square root of means we'll get both plus or minus, no? Yes, but because quantity cannot be negative, no? Quantity cannot be negative, quantity can be only positive. Negative quantity no one can produce, no? That is the reason I took x positive there directly. Alright, otherwise plus or minus we should take whenever you apply square. X is equal to positive 1200, quantity cannot be negative. Quantity cannot be negative. So this is your single variable optimization. We have done both maximization as well as minimization we have done. Now what we will do is, in this single variable only one more is equilibrium. In economics also you might have heard this word, equilibrium. Equilibrium of firms, especially in case of monopolistic competitive firms, for whom equilibrium is applicable. Basically in simple terms, equilibrium is nothing but maximization of profit. In simple words, equilibrium is nothing but what? At that level the profit will be maximum. So I want to find out what is the output at which profit will be maximum, in simple words. Okay, so generally it is applicable for monopolistic competitive firms. See, monopolistic means what? So they are the price setters, basically they are the price setters. There are some barriers to entry also in that particular industry. So what happens is, in this type of industry, if one particular firm say decreases the price, what will happen? Other particular firm, they might be smart, they don't change the price, and that will lead to what? change in their profit. So who is a monopolist? Monopolist is a price setter. So what is the competition you have in this monopolistic? Other firms may take advantage of high price by lowering the price. So if you increase the price, say if you increase the price, what other firms might do? Other firms might decrease the price to take advantage of that. So example, you can take Apple versus Google. Apple phone, Google phone, again compare. So if Apple increases the price, probably Google might what? Reduce the price at a lower price they might do, so that the revenue will what? Increase. So now this particular segment example what I've taken, it is a monopolistic, because that premium is offered by very few players there. That is a monopolistic industry. Now naturally as a firm, what is your objective is, now if I increase my price, other firm is taking advantage of that. So what would be my objective is, I need to fix a price where my profit will be what? Maximum. So even if other firm also take advantage of that, but still my profit I can achieve what? At that particular price I can achieve the maximum profit. Are you getting? Yes, this is what my objective is. So they need to think what price to set in order to earn maximum profit. Both, whether Apple or Google, what they have to in this scenario, because they are competitive firms, what they need to think is, they need to think at what price, what is the profit maximizing price they should fix. So that is their dilemma. So they need to think what price to set in order to earn maximum profit. This is called as, this level, profit maximizing level, price level is only called as the equilibrium. So that is what I was telling you. At equilibrium, MR is equal to MC, if you remember. So what is this equilibrium in simple words is maximization of profit. At what price if I set, my profit will be maximum, nothing else. This is what equilibrium is. So remember this. Equilibrium means profit maximization, remember that. So I was just explaining the concept of equilibrium of firms here. To whom it is applicable? Monopolistic competitive firms. Since if they increase the price, other firm will take advantage. Their dilemma would be what price they should set to get the maximum profit. Okay. So profit maximization, now you already knew that profit maximization, total revenue minus total cost. Yes. So how do you, in case of whenever they ask equilibrium, nothing but profit maximization. So what are the steps now? First you set the equation. First equation is profit equation. How do you get profit? Total revenue minus total cost. This is the first equation for profit. Total revenue, total cost. So two things you should get. First total revenue and then total cost. Then from total revenue you should remove total cost. So then on this you should apply the derivative. First derivative, d by dx of this z equation. So d by dx of tr minus tc. Total revenue minus total cost. Then d by dx of tr, d by dx of total cost. So d by dx of, if you remember, d by dx of total revenue, the first derivative on total revenue you apply, what we call that as marginal revenue. We call this as marginal revenue. Similarly, d by dx of total cost, if you apply the derivative on that we call it as the marginal cost. The first derivative already I told you when I explained the concept, two variables, how we can form the equation. So two variable change is only your first derivative. So marginal cost, the d by dx of total cost is marginal cost. So you can also call this as MR and MC. D by dx of TR is MR, d by dx of TC is MC. So now what is step number 3? Step number 3 is you will equate with 0, no, dz by dx. Nothing but MR minus MC you should equate with 0. MR minus MC is equal to 0, going by this logic. So that means MR is equal to MC. So if you want to get x value, either equate dz by dx value with 0, or you can also equate MR with MC also. The other alternative this is, if you want to get x value, One is already you know the d by dx of your total profit you can compare with 0. I mean you can equate with 0, or MR also you can equate with MC. Like that also you can get X value. Right? Now next condition, you know, if second order derivative is greater than 0, our objective is profit maximization only. No, so what we should get actually, d by the second order derivative must be less than 0, then only maximum point. No, yes. So less than 0 means negative for maximum. So same conditions, because already you know the steps. No, only thing what you should know is equilibrium means at what price they should fix by that is competitive firms to get the maximum profit. That is what you should know. So for equilibrium, whenever they ask you equilibrium in question with single variable, that is nothing but profit maximization. Nothing but what? Profit maximization. So there are two alternatives to do that. One is first profit equation, equate with 0, solve for x, then prove that it is negative. This is one thing. Okay, or what else you can do? MR minus MC is equal to 0, equate MR is equal to MC to get X value. MR is equal to MC, if you equate, then you get what? X. Solve for X. Okay. MR is equal to MC, then solve for X. Next thing is how you can prove that there is a maxima there. This is how you should prove. So proof is d by dx of MR minus MC. MR minus MC is negative. That is what we should prove. To say that we have achieved maximum profit, our second order derivative must be less than 0 or not? Yes. So d by dx of MR minus MC must be negative. Now d by dx of MR, d by dx of MC must be negative. So now d by dx of MR is called as slope of MR. It is called as slope. That nothing but change in marginal revenue with respect to x, that is called as slope of MR, and d by dx of MC is called as slope of MC. So if it goes to that side, since it should be negative, no, that means MR value should be lower than this value, then only it will be negative or not. So slope of MR, if it is less than slope of MC, slope is nothing but second order derivative of MR. Similarly, second order derivative of MC. So if second order derivative of MR is less than second order derivative of MC, nothing but what? Negative only, no. If this figure is greater than, this figure is less than MC, naturally it will give you negative value only. That means condition is satisfied. So either you can use this total profit, you can do derivation, or MR, MC separately you can do to get X value. You can equate MR and MC. Then again perform the second order derivative on MR and MC. If MR, second order derivative MR value is less than MC, then that means condition is satisfied. I hope everyone understood. This is equilibrium. Now let us do a question on this. These are the steps for this. So directly they have gone to multiple independent variable here. Equilibrium. See here, equilibrium is given. A firm is in equilibrium when given the demand and cost conditions, it produces that level of output at which profit is maximized. So conditions, you can see that MR is equal to MC to solve. This is necessary condition. Then sufficient condition is, see here, exactly MR less than MC. That is what I have shown you. Okay. Let us take one question on that. Multiple variable later on will cover. Illustration number 5. A firm has a cost function C is equal to x cube divided by 3 minus 7x square plus 111x plus 50. Demand function is equal to x is equal to 100 minus p. Determine the equilibrium output. Equilibrium output means what? What is the profit maximizing output? At what level of output the profit will be maximum? Equilibrium output, price, and even what is the profit earned also. Three things we should calculate here. So, two alternatives are there. First of all, cost function is given, demand function, quantity is given, x is equal to 100 minus p. And from this demand function only, we'll find out what is the demand function there. X is equal to 100 minus p, and p is equal to 100 minus x. So if you want to get total revenue, we want TR, no, we want to get profit, maximization of profit only, no, objective. So at what level of output the profit will be maximum. So first profit, if you want to get TR, you should get total cost also, you should get TR is equal to price into quantity. So price, substitute now, quantity function already given, nothing but x this is. So p is 100 minus x and quantity is this only, no, 100 minus p. So 100 minus x. I am substituting a price 100 minus x, quantity function is everything in terms of x only we should have, no, everything we should have in terms of x. Then do one thing, what is the price here from this? This is quantity, no? Price is equal to 100 minus, I am able to convert this into 100 minus x. This is my price. I got price now. I should find out price now. What is the profit maximization price? If I want now profit, two things I want. Total revenue minus total cost. Total cost, already we have this function. Okay, now what I want is total revenue. How do I get total revenue? Total revenue is nothing but price into quantity. Total revenue is price into quantity. So total revenue is, now price, if I take price as 100 minus x and quantity as x, what is the quantity? Because already x represents, what I told you now, x represents quantity, no? So I am taking this quantity only. Let quantity be quantity only. Let us not take again 100 minus p. What will happen is, if I substitute there again in terms of p I will get. So what I am doing is, in place of price, we will substitute this equation 100 minus x and let quantity be x only, because x only, no. Then in terms of x only, our total revenue will be. So 100x minus x square. This will be our total revenue. 100x minus x square. And what is the total cost? Already total cost function is also given. X cube divided by 3 minus 7x square plus 111x plus 50. Okay. So now how do you get profit? Profit is equal to TR minus TC. TR minus TC, so 100 minus x square minus what? This you can do, or else what you can do is, separately you can do, MR and MC you can find out separately. D by dx of TR, D by dx of TC you find out, so MR, MC you will get, equate, get the x value, then again differentiate them, then compare the slopes, no. This also you can do, or else what you can do, directly TR minus TC also you can do. Both will give you same answer only. What I am doing is MR, MC separately will find, equate them, then we can solve it. Right, quickly we can finish off, that is the advantage. So how do you get MR? MR is nothing but d by dx of TR. If you do, then you will get MR. On this you should apply the first order derivative. If you want MC, d by dx of TC, if you do, then you will get MC. Right, so on this if you apply, then you will get MC. Compare these two, then you will get x value. So I am doing d by dx of TR, this one, with respect to x. How much I am getting? 100x means 100 minus 2x. This is MR. MC, x cube divided by 3. So 1 by 3 x power 3 means 3 into again x square. So 3 by 3 means again it will get cancelled. So 3x square by 3. 3 get cancelled. So x square. X square minus 14x plus 111 into 1, that is 1 plus 0. So this is your MC. 100 minus 2x, x square minus, this is MR and MC I got. Equate these two for x. So 100 minus 2x is equal to x square minus 14x plus 111. X square, if it goes to that side, x square minus 14, that comes to plus, so minus 12x plus 111 minus 100 plus 11 is equal to 0. So x square minus 12x plus 11 is equal to 0. Okay. So how I can write this? X square minus 11 plus 1 x, can I write like this, plus 11 is equal to 0. Okay, why I wrote like this, you know? A plus b into a minus b, can I write like that? So you can differentiating both sides with respect to x. Here they have done total revenue minus total cost only directly. On this only they have applied derivative. See, anything if you apply both, you will get same only, no? So ultimately they also got this one only, x square minus 12x plus 11 I got. If it goes that side, yes, same thing only. So how you can write this is x square plus minus, I wrote no here, yeah, same thing. So if you solve this now, what you will get? It is like what? A plus x square minus 11 plus 1 into x plus 11. X square minus 11 x plus x plus 11 is equal to 0. So x, if I take common here, so how I can write this one is, can I write like this, x minus 1 into x minus 11 is equal to 0. This can be written as like this. Okay. This can be written as x minus 1 into x minus 11. You can multiply now, you will get the same thing. right? So x minus 1 or x minus 11 is equal to 0. So x is equal to two values we will get. One is 1, other one is 11. X is 1, x is equal to 11. Now you might be wondering, sir, without changing this, this 12 into 11 plus 1, can't you get the answer? The problem is we have x square now, that is the reason. See, a plus b into a minus b, right? That one we covered here. So what are the values here? So what is a here? A is x here and b is what? 11. B is 11. A is x here and b is what? 11. Yes. So x minus 1 into x minus 11, if you multiply, ultimately you will get the same answer only. What is that? X square minus 11x plus 11 only you will get. Right, let me show you now. I will show you. X into x, so x square, x into the minus x. Then minus 11 into x, minus 11x. Minus 11 into minus 1 plus 11 is equal to 0. So x square minus x minus 11x minus 12x plus 11. Exactly we got the same thing. So x1 x minus 1 into x minus 11 is equal to 0. X is equal to 1, x is equal to 11. Two values we got for x. X is equal to 1, x is equal to 11 we got. So these are the x values. Now again we should perform second order derivative. Second order derivative of which one we should perform? The first one. What we got? First one. This is the one they got. D by dx of total profit is equal to minus x square plus 12x minus 1. What they got here. What we have done is MC separately we have done. So what you can prove that is MR, again if you perform second order derivative, even perform second order derivative for MC also and show that MR is less than MC, second order derivative of MR is less than MC, then perfect. So I will do that only now. Continuing with our example. I hope everyone understood here. I have done MRMC instead of total profit. These steps I have applied. Okay. What are the steps? These steps I applied. Instead of applying this, I have applied this. MR minus MC is equal to, so first you need to find out MR. MR is nothing but the derivative of total revenue. MC is nothing but derivative of total cost. Then equate them. You got x2 values. Okay. Then you should find out now second order derivative of MR and second order derivative of MC. Then prove that MR is less than MC. That is what you can do. Otherwise, total profit also you can first do derivation, then equate with 0, then prove that it is negative. Still you can prove that it is profit maximization only. What I am doing is I am taking the values what we got, x square minus 14x equated to 100 minus 2x, two values we have TR and TC. These two values I am taking. TR is equal to how much we got? Derivative of TR what we got? 100 minus 2x. That I am taking. D by dx of TR, which is nothing but MR, 100 minus 2x we got. 100 minus 2x we got. This one. Cost we got x square minus, then d by dx of total cost what we got, which is also called as MC. What I got for this is x square minus 14x minus 14x plus 11. This is what I got. MRMC, already first order derivative is done. No? Then we equated this. MR is equal to MC to get x. What is the x values we got? X is equal to 1, x is equal to 11. No? Yes, two critical values we got. Now what I am saying is last step. Again what you do is d by dx of MR you do. MR is equal to how much you are getting? 100 is constant, 0 minus 2. So minus 2 I am getting. Then d by dx of MC. This one. So x square means 2x. Minus 14. That is 0 only. Okay. Now what you do is put x in this. Already d by dx of MR is minus 2 I got. Now d by put x is equal to 1. How much I am getting? 2 into 1 minus 14. 2 minus 14 I am getting minus 12 I am getting. X is equal to 11 if you put 2 into 11 minus 14. So 22 minus 14 I am getting 7. So that means MR is less than MC. So it means negative only. So if x is equal at x is equal to 11, at x is equal to 11 only it is, this condition is satisfied. No, at x is equal to 1 this condition is not satisfied. So at x is equal to 11 only this condition is satisfied. MR is less than d by dx of MR is less than d by dx of MC only when x is equal to 11. So that means what is the profit maximizing output here? What is 11? By the way, here what exactly is 11? We assumed as x, we assumed as what? The price or the quantity 11 units. So you can see that 11 they might have got here also. So at x is equal to 1 you are getting minus 10. I mean total profit, that is by this but what we want is profit maximization. In fact, what is the question requirement? Equilibrium output. At what level of output profit will be maximum? Price and also profit earned. So maximization we want. So we want greater than. So by the sufficient condition of second order derivative test, there is a maximum at x is equal to 11 only. Yes, correct. Thus profit x is maximum when x is equal to 11 units. So only when output is 11 units your profit will be maximum. So whatever x we got is 11. Now what we should do is we should also calculate the price. So we already we took that price. Price is equal to 100 minus x. No. So 100 minus x, how much we got? 11. So that means 89 is the price. What is the answer price? At 89 the profit will be maximum. And then what is the other one they have asked? Profit earned. What is the profit earned? So simple. What you do is total revenue minus total cost. If you do substitute x value there, you will get profit also. So 89 is the price. Let me see whether they have given 89. Yes, equilibrium price is 89. Now equilibrium profit is very simple. Put that in the equation only. Profit equation. Directly you put x is equal to 11 units. Okay, because the total profit equation consists of only x now. Then you can get the value. You will get 111.33. I hope you understood. So all are equilibrium points only. Equilibrium output, equilibrium price, and then equilibrium profit. Yes, I hope everyone understood. So these are the three types of question: in single variable maximization, minimization, and equilibrium. for single variable optimization. So equilibrium means maximization of profit only. There are two alternatives for that. MR, MC, the other one is total profit also you can differentiate. These are the two alternatives. Either this you can do, directly total profit you can do derivation, first order derivative, second order derivative, or MR, MC also you can equate and then get the answer. Both will give you same answer only naturally, no? Yes. So this is with respect to single variable optimization, my dear students. What is the other one left is multiple variable optimization. Okay. So to get single variable optimization, you need to know derivative formulas and then little bit of economics. Right. So multiple variable optimization I will cover in my other video. Right. So I'll stop this video here, and in another video, the following video, you will get multiple variable optimization. Thank you guys. See you in the other video.